Okay, a piece of candy. All right, sorry. It is, we've got the static coefficient of friction of this and the kinetic of this, right? And in part A, from part A, you need to go watch part A from 8, right? We figured out, we just did mg sine theta, right? Now we don't know m, but we just do 9.81 times sine of 23. We got 3.833 m. So that is our parallel component of gravity acting down the plane, right? And then ultimately we did mu times mg cos theta, right? And this is the kinetic friction, so we used that coefficient, right? We don't know m, but we put in 9.81 and cos of 23, and we got 2.709 m as our friction force. Now these are all in terms of m, but that's okay because ma has an m in it, and it'll cancel out, right? Now this thing is going to be pushed up the plane. It's given a velocity of 4.15 meters per second up the plane. We want to know how far up the plane it goes before it stops. So we got to figure out the acceleration, and then we have to soothe on it, right? As it slides up the plane, the parallel force, of course, is always down the plane, right? So we've got 3.833 m down the plane. Okay, now if it's sliding up the plane, the kinetic friction is also down the plane, right? So there's also 2.709 m acting down the plane. Now both of those are acting down the plane. There is no force acting up the plane. It's only the inertia of the box that keeps it going up the plane, right? So these guys are negative and negative, and now we can figure out the deceleration of the box, right? Okay, so negative 3.833 m minus 2.70. Everything's against it. As you slide up the plane, friction's against you, gravity's against you. Makes sense, right? Okay, and then that equals m times a, so we'll figure out what a is. It'll be obviously negative the sum of those two, right? Okay, so, and I'm just figuring out what these guys are. There they are. Okay, so alpha a, I've stored these in registers in my calculator. So negative 6.542. Now I'm carrying 4 sig figs because, oh, that's not the answer. I'm carrying 4 sig figs because we've got 2, right? And that should be plenty, right? So now let's see, we want to figure out s. I would use v squared is u squared plus 2as, right? So the final velocity up the plane is 0 squared equals 4.15, and that's positive because it's up the plane, right? Squared plus 2 times negative 6.542 times s. Okay, so now we're going to solve for s, right? It's going to be 4.15 squared. Hold on. I'm going to store that exact acceleration. Okay, hold on. So here we go. 4 squared divided by 2 divided by that answer that I got. 1.316 meters up the plane, right? Okay. Yay. Okay, so we've got that answer.